Dear students, in this video we will talk about Schmidt rearrangement. Schmidt rearrangement was reported by K.F. Schmidt in 1923, and he reported the formation of benzanalide from benzophenone and hydrazoic acid in the presence of catalytic sulfuric acid under heating conditions. So benzophenone was reacted with hydrazoic acid in the presence of sulfuric acid under heat, and he got benzanalide. So in principle, Schmidt rearrangement is the reaction of carbonyl compounds with hydrazoic acid or alkyl azides in the presence of sulfuric acid. This is Schmidt rearrangement, and in this rearrangement in general we have three types of conversions. Carboxylic acid can be converted in the presence of hydrazoic acid and sulfuric acid, heat to corresponding amine, and aldehyde can be converted in similar conditions to nitriles, and ketones can be converted to N-substituted amides under similar conditions. So these are general types of conversions which take place under Schmidt rearrangement. Now we see the mechanism. So first mechanism would be the conversion of aldehyde to nitrile. If we see the structure of hydrazoic acid, HN3, it can exist in this form or in this form. So both the nitrogens can attack on this electrophilic center of aldehyde. So in this case we get it attacked by here from nitrogen, and as a result we get this one. In the next step, proton transfer reaction takes place, and we get and in the next step it shifts here, and also protonation occurs from the reaction mixture because sulfuric acid is present. So we get this, and in the next step water is eliminated, minus H2O. We get this, and in the next step proton is eliminated and dinitrogen is also eliminated. We get nitrile. So I hope this is clear to you. We see the next mechanism. Next mechanism is the conversion of carboxylic acid to corresponding amine. In this case, in the first step, carboxylic acid is reacted with sulfuric acid, because in this case both are acids. However, sulfuric acid has lower pKa value than carboxylic acid. Therefore, this is a stronger acid and would protonate a carboxylic acid. So it will get protonated, and as a result we get this positive charge on oxygen, and in the next step this water molecule is eliminated and we get acylium ion, and this acylium ion is attacked by this form of hydrozoic acid, and we get this one, and this can tautomerize into this form. So this is eliminated, minus N2, and we get this one. In the next step, proton is eliminated, minus H plus, and we get nitrine, and in the next step this migrates here and we get isocyanate. And in the previous rearrangements as well, we saw the formation of isocyanate, and isocyanate can react with water to form carbamic acid, and carbamic acid loses carbon dioxide because this is unstable acid to form corresponding amine. So we can see here again we have one carbon short in the product amine as compared to the starting carboxylic acid. So this was the conversion of carboxylic acid to amine, and in this case we have added water to isocyanate to form the corresponding amine, which involved the loss of carbon dioxide. However, if again we use alcohol, we would get carbamate, and we have discussed about this in our previous lectures. And if we treat it with amine, we would get urea derivative. So this is conversion of carboxylic acid to amine, and now we see the conversion of ketones to amides. In this case, we have ketone as a starting material, which is protonated first because we have sulfuric acid as well as catalyst in the reaction mixture. And in the next step, this form again attacks here, and we get this molecule, and this can tautomerize like this. And in the next step, water molecule is eliminated, and we get this molecule. One shifts to this nitrogen, this is eliminated, and we get this one. So water again attacks at this position, and we get this one. Proton is eliminated, minus H plus, and we get this one. This is tautomerized to corresponding N substituted amide. So this is the conversion of ketone to corresponding amide. If we use symmetrical ketone, then we get this amide without any problem of regioselectivity. However, if we use unsymmetrical ketone, we have two different R groups, for example, then we have to see the migratory aptitude of the migrating groups, and the migrating group which will have better electron donating ability would migrate. And this rearrangement proceeds through retention of configuration. In this case, if a stereo center is present during this transformation, the stereo center would be unaffected. So this is about Schmidt rearrangement. If there are any questions or confusion, you can leave your comments in comment box. Thanks.